When we identified autocorrelation problems in the residual term, we need to use the appropriate model to take that into account. So in our lecture, we introduced the three approach. The one with the heteroscedasticity and autocorrelation consistent standard error, the nonlinear model, and an ARDL model. What I'm going to do next is to demonstrate how to obtain those three sets of outputs by using some Stata command. Now let me share my Stata window with you first. Now we are back to Stata. We have already used LM test to confirm we have a high order autocorrelation in the residual term. If that's the case, the first thing that we can do is to request the heteroscedasticity and autocorrelation consistent standard error. So what we can do is to use this command from Stata. So newey, N-E-W-E-Y. That's the command that can give us the ordinary least square regression along with the HAC standard error. So you may notice that the dependent variable and independent variable are the same, but we specify, okay, we have a high order autocorrelation in the error term or in the residual series. The model needs to take that into account and give us the corresponding HAC standard error. So if you press enter, it will give you the regression output over there. We are going to, you may notice, okay, if we compare the coefficient estimate in this column over here, so that's the correlation coefficient. That's the regression with the Newey West standard error. That's another way to say that's heteroscedasticity and autocorrelation consistent. Okay, so this is the first set. And if we compare that with the linear regression result, they are the coefficients are the same, but standard errors are different. You may notice it's difficult for us to make comparison because there's a lot of outputs there. What we can do is to save the output in a variable or in a series. Then later we can display them side by side. We can also put them in a Word document so you can include it in your document. So the first thing to do is to store the value, the estimate in a variable. So the command is estimate store HAC underscore 4. So the name of this new variable or new series is HAC underscore 4. It is directly from the regression model we have just estimated. Similarly, we would like to store the OLS estimation as well. So we need to run the model first because that's going to capture, you're going to put that regression output in the memory. Then we will need to store the result in a different variable. We will call that wrong underscore SE, which means that's a regression with the same set of coefficients. The coefficient estimates are the same, but the standard error are wrong because there are autocorrelation issues in the residual series. So we store that. You may notice that over there, right-hand side, we have two variables saved there already. One is HAC4, one is wrong SE. So essentially, we have the OLS estimation and the HAC standard error model estimation ready there already. So that's the first step. Now let me clean up my screen and go back to the command window. The next step is to estimate the nonlinear model. So to estimate the nonlinear model, we need to use a new command line from Stata. So it's called NL. NL stands for nonlinear. And to use this command line, we have a couple of simple rules to follow. First of all, you need to put the entire nonlinear equation in parentheses. So you may notice that I highlighted in red color. So everything must be within it. That's the nonlinear equation. INF is your dependent variable. Second, every single parameter must be put into braces. So if you put it into braces, that's a constant to be estimated. And everything else, those are your variables. You need to put your variables into this variable function. So you write down variables and open a set of parentheses and put all the variables in there and separate them by spaces, okay? Once that is done, you can press enter to submit it. And we also store the result in a new variable is called NL. So once we press enter, those two lines can be submitted together, by the way. If you copy and paste multiple lines into the command window, then press enter, those lines can be submitted in one go as a batch. That's useful when you have some rather sort of advanced programming, some codes that can run some iteration analysis is useful. Now I'm going to submit these two lines at once. It gives me the nonlinear estimation result. So it estimated the value of B1, row, and B2 with the value and the test result. It also shows me is a iterative generalized LS procedure. So it runs 5 iterations, then we reach the criteria of convergence, it stops, and that's the optimal result. We also have that R squared, and we save the result in a new variable. It's called NL, and right-hand side in the variable list, you will see that variable is there already. We're going to retrieve that later. Just leave it there. The next step is to estimate the third method is this ARDL model. Okay, to estimate the ARDL model, the command line is here. So it's still regression. Instead of just using du, the difference of u, we include the lag term of both the independent and the dependent variable. So that's the lag term of the dependent variable at INF, and this is the lagged first order, first period, 1 period lagged of the independent variable. So if we submit this, that's your ARDL11 model. Similarly, we want to store that in the memory. That's a variable created over there. We store that. You may also recall in my PowerPoint slides, I point out, okay, that one of the variables are insignificant, okay, over there, and I would like to drop it, okay, this lagged variable. So instead of estimating a ARDL11 model, I would like to drop the lag term of the independent variable to estimate the ARDL10. So that's what we're going to have. So everything over there, if you look at the probability column, everything's significant. That's nice. So let's put that in a separate variable. We stored output in that variable. So in total, we have 5 sets of outputs already. It would be nice if we can put them side by side and have a look at the coefficient estimate. To do that, we need to install a command so that we can show the result in the format we want. So the command line is included in that document that I posted online. You can simply just copy and paste. So that's basically we install a sort of a package. It's called EST_out. That's a really nice package for a student. It's a combination, it's a list of useful commands that can help us to manage the outputs. So we installed it. It will take a little while for the software to check whether it's installed already and consistency, whether it's up to date. So it's there. Great. And then the next thing to do is you may go to my document and copy and paste this line instead of writing it. Okay. So ESTTAB is one of the commands included in the package we have just installed. What we ask this command line to do is we would like to have the output, the 5 sets of outputs listed on the screen. And we also would like to have just R squared, residual sum square, and AIC reported. And we also would like to give a name of each one of them. So for example, the first one simply just OLS, the second one HHACSE, but with 4 lags. So if you have this in this command window, press enter, this is what you have. So let me show you the entire output. So basically, it was listed in the order that we specified. The first one is OLS, then that's the OLS, but with HAC standard error. You may notice that the coefficient estimates are the same, but the standard errors are different. And you can compare them with the values on my PowerPoint slides. They are very similar. The difference is just rounding errors. The nonlinear model is a bit different simply because it's estimated using a different command, is NL. That's why the coefficient has different name. What you can do is to, if you can open this, I will show you how to export them into a Word document. And you can move this. This row essentially is just the estimation over here. So row, that's estimation. This one should be moved over here. It's different command line. NL is different name. And this one is just estimation of DU, that's the main effect. So if you move them upwards and remove these two rows, those tables can be compared directly. Okay, so you also have ARDL11, ARDL01 models here, and that shows you the result. Okay, so it's a nice way to store the outputs from different model and display them. So this nice format. Let me show you one last thing under this topic is how to export those results into a document where you can open that later. So you can see using outputs.rtf, use RTF format. So RTF format is the most user-friendly one. It's easier for you to open it either in Excel or in Word document, and use append, because sometimes you need to run the model multiple times. If you use append, the new output will be appended to the end of this document, so you do not accidentally overwrite the previous outputs. But the problem of that is that the document can be really long and could be confusing if you do not sort of label the output appropriately. If you do not want to append, what you can do is just use replace. So each time it will overwrite the previous version of this outputs.rtf and give you a new document. It contains the most up-to-date output only. So if I press enter and I go back to the work directory, my work directory is let me get the work directory first and then show you where is that document. Okay, I went to my work directory and find this file as outputs.rtf and open it in Word, and this is what I have. So that looks exactly the same as what you have seen in Stata, except that that's a very nice format. It's in the Word format. If you copy and paste this into Excel, that works as well. So as I mentioned before, this one, that is the value in the cell, and that should be the value in this cell. So if you remove those, that will give you the output from ordinary square and, with the standard error and the HAC standard error, nonlinear regression, ARDL models. So it's a nice way to summarize and present your result.